Now in this video, I'm going to talk to you about angles of depression and angles of elevation. And first, I want to describe to you what those are, and then we're going to apply it in a couple of problems. So I want you to imagine that you're looking straight out eye level. So I'm going to draw a little eye here to remind you that we're looking out eye level. So if you look out, and then if you scan up and look up, this angle right here that you scan up, like you're looking up at the sky at an airplane. So think of this as the ground, and then you're looking up at the airplane. This is your angle of elevation. Then, if you're looking eye level and you look straight out and then you scan down, that angle that you're scanning down is your angle of depression. Okay, so in the first example, it says a 20-foot ladder leans against a building so that it makes an angle of elevation of 72 degrees. How high up the building is the ladder? So if you imagine, I have a ladder here. Again, I'm sorry, I'm not a very good artist. And we have a building. There's the ground level. It makes an angle of elevation of 72 degrees. So if I'm standing here and I'm looking straight across and then I look up, that would be my angle of elevation, 72 degrees. And we want to figure out how high up the building that ladder is sitting. So if we break this down into a triangle, it says the ladder is 20 feet. So this length right here, which is the hypotenuse, is 20 feet. We're looking for the height that the ladder reaches up the side of the building, and we know that this is 72 degrees. If we're looking at 72 degrees, we have the opposite side that we're dealing with, and we have the hypotenuse. If we look at our trig ratios, the trig ratios that involve opposite and hypotenuse are sine and cosecant. Now, you can use either one, but I prefer to use sine since sine is on my calculator without having to worry about taking the reciprocal. I know that sine of the angle of elevation is going to be the opposite over the hypotenuse. So the sine of 72 degrees is going to be the opposite, which is what we're looking for, which is side H, over the hypotenuse, which is 20 feet. So in order to solve for H, the height up the side of the building, I'm going to have to cross multiply. So I'm going to get 20 times sine of 72 degrees. Now I want to make sure, since I'm dealing with degrees, that my calculator is in degree mode. So go hit the mode button and make sure you're in degree mode, and then take 20 times the sine of 72 degrees. That's going to give you a height of 19.02 feet if we round to two places. So when I put a 20-foot ladder and lean it up against a building at an angle of elevation of 72 degrees, it reaches 19 feet up the side of the building. A woman standing on a hill sees a flagpole that is 60 feet tall. The angle of depression to the bottom of the pole is 14 degrees, and the angle of elevation to the top of the pole is 18 degrees. Find the distance that she is standing from the pole. So if this is the lady, you're getting to see my beautiful art skills. I should go to art school. I'm very talented, if you can see that. She is looking, here's the flagpole. The The flagpole is 60 feet high. When she looks up to the top of the flagpole, that's an angle of elevation that is 18 degrees. And when she looks down to the bottom of the flagpole, that's an angle of depression of 14 degrees. And the question is asking for us to find the distance from the pole. So we want to find this side right here of the triangle. We'll call it D for distance. We want to find that distance. So we've got two triangles here. We're going to set up two equations. So we'll have two equations and two unknowns. Now, the first triangle up at the top, this is a right angle. This distance from here to here, we'll call it h for the height of the triangle. And then this distance on the bottom triangle, this distance here, we'll call it 60 minus h, because it's got to be the difference between 60 and h, since the whole entire flagpole is 60 feet high. So, for example, if h is 20, then this bottom one needs to be 60 minus 20, which is 40. Okay, so we're going to use tangent because we've got D and H. The angle we have is 18, and we're dealing with the opposite and the adjacent side, which would be tangent. So I would take the tangent of 18 degrees is going to give me the opposite, which would be H, over the adjacent, which is D. So there's the first equation. Then the second equation we're going to get from the second triangle, I'm looking at the angle 14, so I'm dealing with the adjacent and the opposite side again. So I'm going to write tangent of 14 degrees is equal to the opposite side, which is 60 minus h, all over the adjacent side, which is d. So now we have two equations and two unknowns. So what I'm going to do is I'm going to solve this first equation with tangent 18. I'm going to solve it for h. H is equal to d times tangent of 18 degrees. So I have 60 minus h is equal to d times tangent of 14 degrees. So all I'm doing is cross multiplying to solve for h. And then I am going to substitute this h, which is equal to d tangent 18. I'm going to use the substitution method and plug it into that h. So that way I can have all d's in one equation and I'll be able to solve for d. So when I plug that d tangent 18 in for the h in the second equation, I'm going to have 60 minus d tangent 18 degrees is equal to d tangent 14 degrees. Then I'm going to add d tan 18 to both sides so I can collect all the d's together. So now I have all the d's together on one side. I'm going to factor out the d, and I'm left with tangent 18 degrees plus tangent of 14 degrees. So my value of d is going to be whatever I get when I take 60 and I divide it by tangent 18 plus tangent 14. So on my calculator, I'm going to put 60 divided by tangent of 14 degrees plus tangent of 18 degrees, making sure that I put parentheses around the entire denominator so the calculator knows all of that is in the denominator. And when I do that, I'm going to get 104.48 feet if I round to two places.